G'day. Today I'd like to talk about the introductory terms you'll need for the study of angles. I have 6 kind of angles here I'd like to briefly show you on the Geoboard. Have an acute angle, a right angle, an obtuse angle, a straight angle, a reflex angle, and full rotation, which is 360 degrees. Back to the worksheet, and I'll go through those again one by one. We're going to start from this position here and go anti-clockwise. So the first angle is less than 90 degrees and greater than 0 degrees. That's an acute angle. So we can put in here 0 degrees, greater than and less than 90 degrees. Now a right angle, you might already know, is 90 degrees. An obtuse angle, well, it's greater than 90 but less than 180. A straight angle is 180 degrees. A reflex angle, well, it's greater than 180 but less than 360. And a full rotation is 360 degrees. Question 1b. Note that all lines and rays in the diagram below are straight. I'd like to start by looking at AC. And note that this line goes on forever in this direction and also forever in this direction. So we draw a line over AC with an arrow in each direction. And this is called line AC. You could compare that to OB. OB starts at O, goes through B, and then goes on. So it has only one arrow, and this is called ray OB. Point O here is called the vertex of the angle, where the lines intersect. Intersect is a verb. The noun is intersection. So this is an intersection of a line and several rays. COD. Note that to talk about this angle, I use the point on one arm, C, the vertex, O, and D, the point on the other arm. And I put a hat over the vertex, and that's called angle COD. And it's a right angle. It is also called a perpendicular. Now I have 3 angles here, AOE, so let's say AOE, that's that angle there, and EOD, EOD, so that's that angle there, and DOC, DOC. Note that I can call this DOC or COD, it doesn't matter. They total 180 degrees, as indicated by this line here. They are adjacent angles. which just means next to one another. They're next to one another, and they total 180 degrees, and that's because they are angles on a straight line, which in this case is AC. The sum of all angles at a vertex. So if I start with this arm here, OD, and I go all the way around and back to OD, well, that is 360, obviously, and they are called angles at a point. And lastly, ED. Note that ED starts at E and finishes at D. So we draw a line over the top with no arrows, and that's called line segment ED. That completes page 1, and if we'll move on to page 2, there's some more terms. The interior angle sum of polygons. Now in a triangle, the sum is 180 degrees. In this triangle, this angle plus this angle plus this angle equals 180 degrees. In this triangle, this angle plus this angle plus this angle equals 180 degrees. In this triangle, we have a right angle. So the right angle accounts for 90 degrees, so the other two angles will sum to 90 degrees. And if two angles add up to 90 degrees, they are called complementary angles. So angles A and B are complementary. Now we can look at the interior angle sum of a quadrilateral. Quadrilateral means four-sided polygon, and its interior angle sum is 360 degrees. So in this quadrilateral, this angle plus this angle plus this angle plus this angle equals 360 degrees. This is a special quadrilateral. It's a square. Its four angles are 90 degrees, 90 degrees, 90 degrees, and 90 degrees. In this quadrilateral, I have two right angles. Well, they will account for 180 degrees. So the other two angles, E and F, will total 180 degrees. Now, where you have two angles that total 180 degrees, they are called supplementary angles. So angles E and F are supplementary. I'd like to talk now about the interior angle sum of any polygon. We have a formula for this. It is the number of sides minus 2 multiplied by 180 degrees. So in the case of a triangle, which we've already done, it is 3 sides minus 2, which is 1, times 180 is 180. And in this column here, I ask if the polygon is regular. Now, regular means all sides and all angles are equal. So if a triangle is regular, it's an equilateral triangle. And we can divide the total number of interior degrees by the number of angles, 3, so each angle is 60. In the case of a quadrilateral, if we put this in our formula, we get 4 minus 2 is 2 times 180 is 360. And 360 divided by 4 gives us 90 degrees, and of course a regular quadrilateral is a square. If I have a pentagon, well, a pentagon has 5 sides, so it's 5 minus 2 is 3 times 180 is 540. Divide by 5, and each angle is 108. The next is a hexagon. Now, just in case this isn't clear, I'll do this one on the whiteboard. If this were a regular hexagon, it would have all sides and all angles equal. Now we know from our formula that the interior angle sum of this polygon would be 6 minus 2 times 180 degrees, which is 4 times 180 degrees, which is 720 degrees. It has all angles the same, in this case 6 angles the same, so we just divide 720 by 6, and the answer is 120 degrees for each angle of this regular hexagon. So a heptagon has 7 sides. We put that in our formula. We get 5 times 180 is 900 degrees. If we divide this by 7, assuming it's a regular heptagon, we get 128.57 degrees. An octagon has a total interior sum of 1080 degrees, and a dodecagon has 12 sides and has an interior angle sum of 1800 degrees. Divide this by 12, and each angle of a regular dodecagon is 150 degrees. This is a very good formula to remember. Now I'd like to move on to question 3 of the worksheet. This is a typical angles problem where we're asked to find the measure of an unknown angle like x, but we're told different things about the polygons in this picture, and they are indicated firstly by these hash marks, they're called, and this means that this is an isosceles triangle, that this side equals this side, and a property of the isosceles triangle is that each angle opposite the equal side is equal. So that means that if this is 65, this is also 65 degrees. In other words, in an isosceles triangle, the base angles, as they're called, are equal. Now that leaves an angle here that will be 180 degrees minus 2 times 65, 180 degrees minus 130, which is 50 degrees. Now, because these are straight lines, this forms what is called an opposite angle, or a vertically opposite angle. And vertically opposite angles are equal. So this is also 50 degrees. In the bottom triangle, we have a right angle. So therefore, these two angles, x and 50, are complementary. X will be 40 degrees. If we move on to question 4, slightly more difficult, we have to find all these angles, R, S, T, U, V, W, X. But again, we're given some information both on the diagram and in this box that says given about the polygons here that's going to help us. The first thing to note is that this triangle, CDE, is equilateral. The hash marks also indicate it has 3 equal sides, and that means 3 equal angles. If you remember from the table we did just before, each angle was 60 degrees. We can safely say S is 60 degrees. I'm also told that T equals 2R, because they're angles on a straight line, R, S and T. So I could say that R plus T plus 60 equals 180. Substitute 2R for T and I get R plus 2R, and then I'll take 60 from 180 and get 120. And that will mean 3R equals 120, and that will mean R equals 40. And T is 2R, T is 80 degrees. Now R and U, because these are straight lines, are opposite angles, so U is 40 degrees. And here we have another triangle, EFB, and we see by these hash marks it's isosceles. Therefore, angle V will equal angle W. Now we know angle U is 40. So V and W will be 140 degrees over 2, 70 degrees. Angle X is called the exterior angle of a triangle. It is the sum of these two angles, U and W. And U and W is 40 plus 70 is 110 degrees. Of course, we also know that another way. If V is 70, angles on a straight line tell us that X is 110. But it's a handy thing to know that this angle equals the two non-adjacent interior angles. Okay, that completes my introductory terms for angles, and you can find further worksheets with angles problems on my website, math@geoboards.com.